Yeah, hello everyone. Uh, so today we'll be looking at the most basic sequential circuits of all, that is the SR latch. It is also called as a NOR latch. Okay, so here you can see the logic diagram of the SR latch over here. So S in the SR latch stands for set and R in the SR latch stands for reset. Okay, in any digital system, setting something means making output high. So if I am setting something, that is I am making set is equal to 1, what happens is the output becomes high. Setting something is making something 1. In the similar vein, resetting something, that is if I give 1 to reset, okay, resetting something means making the output 0. So that is we'll be making q is equal to 0. Okay, so we can say that the SR latch is nothing but a set reset latch. Okay, so when set is equal to 1, the output becomes 1. When reset is equal to 1, the output becomes 0. Those are the meanings of the terms set and reset. Now this of course this is our SR latch. As you can see, there are two NOR gates present over here, and of course it is cross coupled. Okay, the output of this NOR gate is given as one of the inputs to this NOR gate, the top NOR gate, and the output of the top NOR gate is given as one of the inputs to this bottom NOR gate. So it is a crisscross kind of arrangement. Okay, and in order to analyze this particular circuit, we have to first understand the truth table of a NOR gate. Okay, so first let us write down the truth table of two input NOR gate. Okay, so we'll see the truth table of two input NOR. So like we have discussed previously. Okay, so in any truth table there are two sides. On the left hand side we have the inputs. Okay, so let the inputs be a, b, and let the output be y. Okay, so of course we populate the truth table always in the ascending order. Okay, so this is always 0 0 0 1 1 0 1 1. Okay, so the expression for an OR is nothing but a or b whole complement. I think most of you are very well versed with the basic gates, so this shouldn't be a problem. So 0 or 0 we know is 0, but its complement is 1, so this is 1. 0 or 1 is 1, its complement is 0, so this is 0. 1 or 0 is 1, its complement is 0, and 1 or 1 is also 1 and its complement is 0. Okay, so this is the truth table of a typical of any two input NOR gate. Okay, so now I want to summarize this two input NOR gate. If I can summarize this two input NOR gate, I can make the following statement. Okay, if at least one of the inputs to a NOR gate is high, the output is low. Okay, I can make that statement for this particular NOR gate. Okay, if at least one of the inputs is high, the output is low, else the output is high. Okay, see, in this case none of the inputs is high. Okay, so the output is high. Okay, in the second case one of the inputs is high, b is high, so the output is 0. In the third case one of the inputs is high. Okay, here a is high, so the output is 0. Okay, in the last case both inputs are high. The statement I made is if at least one of the inputs is high, the output is low. So here both the inputs are high, so the output is low. I think in order to summarize, so for a NOR gate, this is not for all gates. This summary, this verbal summary is only for a NOR gate. Okay, if at least one of the inputs to a NOR gate is high, okay, output is low, else output is high. Okay, so with this piece of information, this is nothing but the summary of the two input NOR gate. With this piece of information we can basically try and analyze this SR latch. Okay, So now let us revisit the SR latch. Okay, so there are two inputs to this SR latch, S for set and R for reset. Okay, there are two outputs, Q and Q complement. Of course, Q and Q complement are complements of each other. So if Q is 0, Q complement is 1 and vice versa. Okay, so and then there are two inputs S and R. You have seen it here. Okay, now in order to analyze any circuit, okay, we can try and come up with a particular truth table of that circuit. Okay, so here I'll try and come up with the truth table of this SR latch. Okay, so let me identify the inputs and outputs on the SR latch. So what are the inputs? The inputs are SR. Okay, these inputs on one side of the truth table and the outputs on the other side, Q and Q complement, Q bar or Q prime, whatever. Okay, so here we have two inputs, so we have four combinations, 0 0 0 1 1 0 and 1 1. So let us analyze the circuit for all these cases. And then we can draw some conclusions based on those. Okay, so that is the whole idea, how we are going to proceed further. Okay, so let me go case by case. For that I need the picture of an SR latch. Okay, so let me bring this here. Okay, right now, yeah, so I want to analyze this SR latch. Now the first case is 0 0, second case is 0 1, third is 1 0 and fourth is 1 1. Okay, so first I'll analyze the case where S is equal to 0, R is equal to 1. Okay, I'm not going sequentially here, so ideally I should have done this first, but I have taken a small detour. I'll start with this case, then this case, okay, then this case, and then I'll go back to 0 0 case. Okay, right. So first, if S is equal to 0, R is equal to 1, so what is happening? So the S is made 0 and R is made 1. Okay, so from our understanding, the verbal summary that we made earlier for a NOR gate, which is nothing but if at least one of the inputs to a NOR gate is high, the output is low. Here if you see, I labeled these two NOR gates as N1 and N2. If you see, one of the inputs to N1 is 1, because the case that we are considering is S is equal to 0, R is equal to 1. So one of the inputs to this NOR gate N1 is 1. So we can readily predict the output of this NOR gate, which is going to be 0. From the property of the truth table, we have observed this already. Now let us come to this. Now this the NOR gate N2. So this 0 now appears at one of the inputs of N2, and S is already 0, and 0 NOR 0 is 1, that we have already seen. Okay, so if S is equal to 0, R is equal to 1, what are the outputs that we got? We got output Q as 0 and the other output Q bar as 1. This is what we have already expected. I told you that previously at the start of the lecture, resetting something means making the output 0. So when you give R is equal to 1, the output Q becomes 0. So that is what is happening here. You can directly see the correlation. Okay, so I asked the SR latch to reset by making R is equal to 1, and it made Q is equal to 0. That was the previous understanding we had earlier. Okay, right. So one of the cases has already been analyzed. When S is equal to 0, R is equal to 1, the output Q is 0 and Q bar is 1. This case is done now. Okay, now let me go ahead and analyze the other cases in the upcoming video.